So this is Augustus de Morgan. He's one of the coolest names ever. Okay, and he determined that any Boolean function can be created using NOR and NAND gates. Now that's something we're not actually going over in this video. We're focusing on the three De Morgan's laws and showing you how to apply them when simplifying expressions. But that is certainly something I'd suggest the top end students want to be looking into, just to understand how NOR and NAND gates are used to represent anything that you need to represent. They're known as the universal gates, by the way. Right, so I'm going to go through this relatively slowly because I think this is a video that's going to be watched quite a few times. All right, so De Morgan's law is a way to simplify Boolean expressions following just three rules. Okay, and it's quite simple once you've practiced it. Number one, the logical connective must be changed. Don't worry if you're a bit lost with this. We're going to do some questions in this sort of video. Number two, the logical state of each variable must be changed. Number three, the logical state of the complete expression must be changed. Okay, so let's try it and see what the hell I'm going on about, basically. So we're going to apply it to this basic expression at the bottom. Okay, so we'll start simple. So the first one is we must change the logical connective. So that means pick the operator that you're going to work on and change it. Okay, so if it's an AND, it becomes an OR. If it's an OR, it becomes an AND. Then the logical state of each variable must be changed. So if it's an A, it must become a not A. If it's a not A, it must become an A. Okay, so you not each side, not each variable, and then we're going to not the entire expression. So what we're trying to say to you here is that is a simplified version of that. Or realistically, we kind of work this backwards. If you were given that in a question, that means exactly the same thing as that. So that would be the simplified version of that. Now, that seems strange, but when you look at it in a truth table form, it will make total sense. So what we've got here is we've got A, B, and we've got A and B, which we know would equal 0, 0, 0, 1. On here, we've got A, not A, B, not B, A or not B, and then the inverse of A or not B, which is that expression there, which you can see is 0, 0, 0, 1. So if you follow this truth table, pause the video and follow it through so you make sure you truly understand it. What we're saying here is that is exactly the same as that. So obviously, if you came across that in your simplifying question, you could turn it into that by following those three rules. Okay, now this is more like a question you could face. Simplify the Boolean expression below, showing your working. So because it doesn't say apply De Morgan's law, it's just saying simplify. That highlights we're probably going to need to use our Boolean simplification skills alongside maybe the application of De Morgan's law to turn that, which looks a complete mess, into something more understandable. So straight away, hopefully after watching, if we go back to the last slide, sometimes if you see things that look relatively similar to that, that would be the best place to start. Because I could apply De Morgan's law to any of these three operators, these connectives, but I'm going to focus on this one. Okay, so I'm going to focus on this one because it screams out that you should probably apply De Morgan's law there. So I'm just going to take that section out for a second, and I'm going to basically say apply De Morgan's law. So I need to change the operator. So I change it from a plus to a dot. I'm going to invert I'm going to effectively not each expression and then not the total. But as we know, double knots cancel out. So I'm basically saying that not A or not B is the same as saying A and B, which we should know is true based on what we've just done. Okay. Then if we look at our question again, we've now got a slightly simplified version of our question. Okay. So now we can continue, now we can continue to simplify it. So we know B and B can be can be simplified to just B. So B or B, that's one of the simplification rules we went through. So now we've got A and B and not A. Well, we also know that when you've got it like this, where you've got the same operator, you can swap the letters round and that's okay. So we could swap the letters round and we could think A and not A is the same as saying 0. So we could change this to B and 0. And if you've got B and 0, you can simplify that down to just B. So what we're saying here is that whole thing there can be simplified down to just B. Okay. To prove it, we've got A we've got B. We've got not A, we've got not B. We've got B and not A, which is that side of it, and we've got A or we've got not A or not B, which is that side of the expression, and we've got Q, which equals those two things ORed. So if either of those are a 1, Q is a 1. And you'll notice the Q column here is exactly the same as the B column here. I know I've done it, usually I'd go 0, 0, 1, 0, 0, 1, 1, 1, but it doesn't matter. As long as I've got the 4 combinations, so you can see B, 1, 0, 0, 1, Q is 1, 0, 0, 1. So that does actually simplify it all the way down to B. Now you can do a truth table simplification to get an answer, but what you'll find is in exams, sometimes they'll say it's a 5-mark question, 4 marks for the simplification, 1 mark for the answer. Because this, while you can get the answer by doing the truth table, because this doesn't demonstrate an understanding totally of how, you might find you limit yourself to just the answer marks and not the working marks. Okay, so we'll go through one more now. I've forgot my pen to write on the screen, so I'm going to have to show you the answer and talk through it. But we've got another one. Now, this one, the key thing to highlight here is it says apply De Morgan's law. So because it says apply De Morgan's law, you know that sometimes it helps you there to say you should be using De Morgan's law and not just simplifying. Now, De Morgan's law, there's 2 ways to get to the answer here. Now, I'll show you the way I do, but basically you've got to pick, it's 2 because there's 2 operators. So you've got to apply De Morgan's law to one of these 2 operators. So I personally would go for that one. Okay, so we treat that as the right side of the operator, that as the left, because that's got brackets on, and then we'll knot the thing. So to get from there to there, all we're doing is we're changing the or to an and. We're knotting the A and we're knotting the B and A, and then we're knotting the total expression. So if you do all that, remember that's turning into an and, you get that. Then we get rid of the knots, and we can get rid of them, and then we can ignore the brackets because they're all the same operator. Okay. So yeah, we just ignore those because remember, if you're not something, you are it. So when you get rid of those, that turns to that. Now, the answer is A and B. That's because if you've got, remember, A and A can just simplify down to A. So if you've got A and A, we can cross off one of those A's. So the answer is A and B. Now, I could have done it another way by applying De Morgan's law to that operator there, but personally, that is the route I would have gone. Now, we've gone for a few examples there. The best thing you can do with this is practice. Okay, old exam papers that they've all linked and sorted for you. They're the best place to practice this skill.